So in our last physics class, we were able to do fundamental and derived quantities, and today we are going to be moving to another very important topic that we're supposed to know as beginners in physics. Now this topic is units, multiples and submultiples. Now unit itself is something that is extremely important, that if you don't know unit, I have no doubt that it is not possible for that kind of person to pass physics. The person will not pass. It's not feasible. The feasible that I'm saying is the FEASIBLE. It can never happen. So you have to be very conversant with your units before before you be able to perform very well in your physics. Now, so what do we call units in physics? What do we call units in physics? So in physics, we record values of data obtained from experiments. That means after you do an experiment, maybe an experiment where you are supposed to measure a particular quantity, you are supposed to measure a change in a particular quantity, you are supposed to measure the value of a particular quantity. So these recorded values, when checked, always have two parts. So that means that any value that we are going to record in physics, it must have two parts. Now what are those parts? The value. So that means it must have a value. Maybe after you measure something, you measure it to be 20, you measure something to be 30. These are what? These are the values. So you have the value and also the unit. So which means that just writing 20 in physics is not enough. Just writing 30 in physics is not enough. You have to tell us 20 what, 30 what. You have to add another thing for it to be what? To be complete. Now, so no report is complete without these two parts. So if you are given any report for the measurement of a value and it doesn't have these two parts, which are the value, in physics we always call value, we always call it magnitude, but they are still the same thing. That's just the size, how big it is. So without those two parts, which are the value and the unit, it is not possible for you to write that value down and just put only the value. You don't put the unit, or you just write only unit, you don't write the value. It is very wrong. So units are very important in physics. Now, so no report is complete without these two parts. So a unit will let us know what is measured. A unit will let us know what the measured value denotes. That's another thing. A unit is going to let us know what the measured value denotes. That's like a common sense. So it doesn't make sense for you to just write 10. But immediately you put m. In physics, we use m to represent meters. So this already is telling us that what? You are measuring length. If you don't put m, let's say you put capital letter N, this N represents Newton. That means you are measuring force. It's either you are measuring force or you are measuring weight. We measure those two in Newton. Or you are measuring tension. Tension is also measured in Newton. So you must add something to it for it to make sense, for it to have meaning. You can add capital letter J. J is what? You use J for joule, which is a unit of measuring work or energy. So it is very important that you add unit to anything that you want to give in physics. Without it, you are just writing what does not make sense. So writing 50 on its own makes no sense in physics. Writing 50 on its own makes no sense in physics. But adding m already tells us we measured length, and adding s already tells us that we measure time, and if you add J, it is telling us that you are measuring work or energy. So what does this mean? So what this means is that we can also think of units as an identity for quantities. We can also think of units as identities for quantities. So which means that whenever a unit is added to a particular value, we are going to know the quantity that was measured. Even if you are not going to be exact about that quantity, you are going to know something about that particular quantity that was measured. Just in the case of length, so let's say we have 10 meters. So this 10 meters, although we know that it is a measurement of length, but we are not sure which kind of length, because length is of different types. You can have a length along a straight line. This one we call it displacement. You can have length along a line that is not straight. We call this one, we call it distance. So whenever they put meters, we already know that it's either they are measuring displacement or they are measuring distance. So that will give us an idea of what was measured. Another one is joule, just like I said before. This is telling us that it's either they measured energy or they measured work. So it's going to be easier for us to narrow down those quantities that it can be. So never make a mistake of reporting values without units. Don't do that. If you do that, it's automatic failure. Now, so let's look at some of the quantities that we have and their units. Now, I am knowingly using the fundamental quantities. I'm knowingly using the fundamental quantities, the 7 fundamental quantities that we have in physics. Those are the ones that we are going to discuss their units for today. Now, all other quantities that we have, even if you don't know their units, you can get their units from the unit of fundamental quantities. That's why it's very important for us to know very much about fundamental quantities. Now, so what are their units? So for mass, we measure mass in kilogram. We measure mass in kilogram. We measure time in second. We measure length in meters. We measure temperature in Kelvin. We measure amount in mole. Measure current in ampere, and we measure luminous intensity in candela. So those are the units of these 7 fundamental quantities. So we must know them. We must make sure we know all of them like this, and also their units. So you shouldn't doubt anything, which means that if I just come and I just say something is maybe 10 Kelvin, this is telling you that it is what? It is temperature that they measured, and the value is 10. So this K is telling you that it is a temperature. Why this 10 is telling you the value of that particular temperature. So automatically you won't be doubting what they have given you. So let's say somebody wrote 20A. This is what? This A tell you that what? You can match A to current. So that means that this is current that they measured, and the value is what? 20. So those are what? Those are the very important function and advantage of what? Of units. So just try to memorize these quantities that I just showed and know their units. Now, another thing we need to know is that mass and length can also be measured in gram and centimeter respectively. Now, if you look at this, for mass we said it is measured in kilogram. For length we said it is measured in meters. But they are not telling us here that if you like, you might measure mass not in meters, but you can decide to measure it you can measure mass not in kilograms, but you can decide to measure it in gram. You can also measure mass in gram, but if you look at it very well, you see that kilogram is still related to gram, because gram still shows inside it, isn't it? So you can also measure mass in gram instead of kilogram, and you can also measure length in centimeters instead of meters. There are also other units of length. There is mile, there is mile, there is what do they call it? There is another unit that we use to measure length apart from miles. I can't recall for now, but we also have other units. So you must know that these are not the only units that we use to measure all of these quantities. There are also other units that we can also use. Now, so but those units are not the standard units. That's it. So whenever you see that they measure length, they now write 10 centimeter. Although this is correct, but it is still somehow wrong, because length must always be in meters and not in centimeters. So you must try to convert it back to meter, so that it's going to be fully correct. So now you should know something. So they said they are not the standard units, so which means that these ones that we have lifted here, they are what? They are the standard units of measurement. They are the unit of measurement that if you leave your answer in those units, nobody is going to question you. But if you leave your answer in other units, you might be questioned, unless the question is telling you, maybe for example, in a question you are asked to calculate length, then your answer, you now got 10. The questioner said leave your answer in centimeters. That means that if you write 10 centimeter, you are correct, because the instructions have already told you to leave your answer in centimeters. But if the instruction does not tell you to leave your answer in centimeters, then your answer must be in meters and not in centimeters. So if the question does not give you any instruction and you leave your answer with the standard unit, which is meter, or if you are measuring mass, you leave your answer with the standard unit, which is kilogram, then you are correct, because the question did not give you any instruction to follow. But if they did not give you any instruction and you leave your answer in maybe centimeter, there is a possibility that you might be questioned, because this is not what the standard unit of measuring the length. Now, so the standard units are also called SI units. That's what you must know. Standard units, we call them what? SI units. So they are those that are mentioned above. So those are the ones that we have mentioned here. Those ones that are here, we call them the SI units. That's one thing that we must know. We call them SI units. They are the standard units. Now, they are abbreviated as what? As MKS. We abbreviate these units as MKS. Especially, we usually use the three fundamental units. Like the first three fundamental quantities. Those are the ones we usually use, which are what? Mass, length, and time. So for those first three, you see that mass is in meters, so that's where we got the M. You see that length is in meters, that's where we got the M. Then you see that mass is in kilogram, that's where we get the K. Then you see that time is in second, that's where we get the S. So we call them MKS system of units. That's if you are using the standard, we call them what? MKS system of units. But if you are not using the standard, for example, if you went and measure mass in grams and you measure length in centimeter, then we call it what? CGS. So this C is from centimeter. Look at it here. The C is from centimeter, then the G is from gram, and the S is from time, which is second. So you can if you like, you can use the MKS, and if you like, you can use the CGS, but they are not the same thing. They are not the same thing. So if the question does not tell you anything, use the standard, which is the MKS. MKS means you are measuring mass length in meters, you are measuring mass in kilogram, you are measuring time in second. But CGS means you are measuring length in centimeters, you are measuring mass in grams, and you are measuring time, you are still measuring time in seconds. So note, if you are given instruction, always follow the instruction. But if you are not given instruction, use the standard. So that is it. Now, what else do we need to know? So we need to know about multiples and submultiples. So they are telling us here that the multiples and submultiples are prefixes added to units to increase or decrease them. So these values, these prefixes, we add them to units. What do we mean by prefix? Something that comes before another thing. So that means that we write that particular thing before we write the unit. We are going to write that thing before writing the unit. And what's the function? Is either to increase that unit or to decrease the unit. Now, it is multiples that are going to what? That are going to increase the unit, while submultiples are those ones that decrease the unit. You just think of it, when they say something is a multiple of something, that means it is many more times. So that's why we say they increase. While sub, when they say something is sub, that means it's under something. So that means that one is going to do what? It's going to decrease that particular unit. Now let's look at some of them. Now some of the multiples that we have what? We have deca, we have hecto, we have kilo, and we have mega. Now these are like 4 of them that we need to know, that we use in physics to increase the value of quantities. Now you see that they have their own way of writing them. So they won't write it in full. They won't write it in full as deca. They'll just write it as dA. Instead of writing hecto, they will write h. Instead of writing kilo, they will just write k. That's why when we wanted to talk about mass, we said we measure mass in kilograms. We measure mass in kilogram, kg. So ordinarily it's supposed to be gram, but because we want to increase it, that's why we put k before it. This is the meaning of it being a prefix. So that means before you write that gram, which is for mass, you must put that prefix before it, so that it can become kilogram. So those prefixes, we add them before those values. Look at the CGS system also. You know, we said we measure length in centimeters. So let's say we have 10 centimeter. So this meter is the original one for length, but we add this prefix to it, which is centi. So we later, although it's not here, so these ones are multiple. Centi is an example of a submultiple. It reduces the value of the unit. It reduces the value of the unit. But since we are looking at multiples first, that's why you can't find centi among these ones. So now, how do we know this? Now, anyway, you see deca, which is dA, it means that you are multiplying that value by 10. It means you are multiplying that value by 10. That's the meaning of deca. So, for example, if somebody writes 2 dA meter, this is what 2 decameters. This is 2 decameters. What it means is that 2. Now you now go and look at what deca represents. Deca represents 10. So you now say times 10, then you now put your meter. So which means the original value is actually 20 meters. That's what it means. Or you see that somebody writes 5 kilogram. What this means is that we have 5, then this kilo, you go and look at the value of kilo. Kilo is what? Multiply by 1000. So you multiply it by 1000, then you put your gram. So this is what? 5,000. This is 5,000 gram. So that's what? That's the value of 5 kilogram. So you have to know all of these stuffs. They are very easy. So if you have mega means multiply by 1 million. So you have to know them. Mega means we are multiplying by 1 million. Now, what of submultiples? Now, submultiples, we have deci, we have centi, we have milli, and we have micro. Now, how do we use them? Now, deci means you are dividing by 10. So that means it's the opposite of deca. No, deca means you are multiplying by 10. So deci now means that you are dividing by 10, because this is what? 0.1. So if somebody says we have 20 decimeter, what it means is that you have your 20, then deci is what? 0.1, right? So you say multiply by 0.1, then you put your meter. So this will give us what? 2 meters. So as you can see, 0.1 times 20, we remove this 0, and you are left with just 2. So that's the meaning of what? Deci. So that means that you are dividing by 10, because since this 0 is not here again, it means that you have divided this 20 by 10. Now look at centi. Centi is what? 0.01, or you say divide by 100. 0.01 is the same thing as divide by 100. So let's say somebody said the value of a length is 200 centimeter. What does that mean? That means it is 200 multiplied by centi. What is centi? 0.01. Then you put your meter. This centi, you see that is not there again. It is the one that we have replaced by 0.01. Now by the time you multiply this 0 will cancel this 0, this 0 will cancel this 0. We are just left with 2 meter. So the value of that length is actually 2 meter. But to make it look big, to make it appear as if it is big, although they reduced it to make it appear as if it is big. That's why they put this centi. So centi means you are measuring in smaller units of meter. So that means that the value that you now have is now going to be bigger. But if they put a multiple behind it, that means that you are measuring in big units of that particular stuff. Then the value that you are going to have is going to be smaller. That means you are taking it in bits. Just look at it. Let's say we have something that is 50, and they now said, be taking this 50, be taking it to 2. How many times are you going to take it to finish it? You are going to take it 25 times. That's because we are taking it 2 times each time. But if they say be taking it 10, what will you notice? You are going to take it only 5 times if you are taking it 10 at a time. So which means that when we are taking it in smaller values, we have a big answer. But when we are taking it in bigger values, we are having a small answer. So that's what it means. That's actually the meaning. So if something is having a multiple attached to it, it means that they are measuring, they are taking it in big values, so it will now have a small answer. But if it is attached to a submultiple, that means that they are taking it in small values, so it will now have a big answer. So milli means we are dividing by 1000, or we are multiplying by 0.001. Just look at it. Let's say we have 300 milliseconds. So this is the same thing as, sorry, that's 3000. So that will be 3000 multiplied by 0.001 second. So this will cancel this, this will cancel this, this will cancel this. We are left with what? 3 seconds. You see that the value is now what? It is small. Before it was 3000, but because we are taking it in smaller values, that's why it look as if it is big. That's why it is 3000. But by the time we were taking it in bigger values, which is just the normal value, is now reduced to 3. So look at that. So this is actually the same thing as, instead of just multiplying it by 0.001, you can just say it is the same thing as divide by 1000. So all these 3 zeros will just cancel these 3 zeros. It should still give you 3 seconds. So while micro just means that you are multiplying by 0.00001, or you are dividing by 1 million. So other ways of writing this is, instead of writing this, you can say this is 10 raised power minus 1, this is 10 raised power minus 2, this is 10 raised power minus 3, and this last one is 10 raised power minus 6. So those are the other ways that you could have written them. You see that it somehow corresponds with what we have here. The first one is 10 raised power 1, the second one is 10 raised power 2, the third one is 10 raised power 3, and the last one is 10 raised power 6. But note something, these are not the only multiples and submultiples that we have. We also have other ones, but these are the most common ones.